As we start chapter 7, which is about radical expressions and radical equations and radical functions, we first just start off by simplifying radicals. We'll be simplifying, we'll be looking at different ways we can write radicals. We'll be working with operations, adding, subtracting, multiplying, and dividing, and then we'll get into solving equations and graphing functions. So here we are at the very beginning with simplifying radicals. We'll go ahead and start off with this definition here, and this says for any real numbers, so we're talking about real numbers, a and b, and any positive integer n, so we're looking over here, a to the n equals b if a is the nth root of b. The radical sign indicates a root. The expression under the radical is called the radicand. So over here we have a radical expression. Here's the radical sign, the index, and then the radicand. And we remember from before when you learned square roots or radicals that in this we're asking for how many or what number to this power, to the n power, would equal b. So a to what power equals b. It is good to be familiar with your perfect squares and perfect cubes. This is a list that you should know. You should know a lot of them already. And this is really helpful as we move forward with simplifying. So let's go ahead and jump into examples, remembering these numbers right here. And just to remind you of what we learned back in chapter 5, you can take odd roots of negative numbers and get a real number answer. So I'm thinking like the cubed root of -8, you can get a real number answer. It's a -2. But you can't take even roots of negative numbers and get a real number answer. It will be imaginary numbers. So just remember that as we work through here. As we look across these 5 examples, we do see numbers that were in those lists that we just mentioned, perfect squares and perfect cubes down here. So the cubed root of -125. So we start right away with one of these cubed roots. You can take odd roots of negatives. So we can have an odd here, an odd in our index. So if we think what times itself 3 times will give me -125. Well, it's got to be a negative number, so negative. And 125, if you remember, is 5 times 5 times 5. So -5 is the answer to that. Notice once we take the cubed root, we don't put a radicand here anymore. Part B, we have the 4th root of -16. Well, we can take the 4th root of +16. That would be 2, but we have this negative number here, so this has no real roots because we can't take the even root of a negative. The next one, part C, the square root of 1600ths or 0.16. 16 looks familiar. We don't usually see it in our list as 1600ths, but that gives us the clue that something about 4 should work. So let's just try this. Let's first try. Some of you might think, well, maybe it's 0.04. So that means 0.04 times 0.04 would equal this. There's a couple ways we can think that this wouldn't work, but let's go ahead and multiply it. 16 is 6, add the 1, 16. And then this is just a 0, but we would have to move this over 4 places. And so 0.04 times 0.04 is 16 10,000ths, which is not what we want. So we're going to try 0.4. So what's 0.4 or 4/10 times 4/10? And this is 4 times 4 is 16. We move the decimal over twice, and that is what we wanted. So our answer is 4/10. Now, the reason is, if you remember, if you take a number and multiply it by a number smaller than 1, which is 4/10 is smaller than 1, you're going to get something smaller than your original. So be careful of that when you're working with decimals. But the square root of 1600ths is 4/10. Over here, this next one, we might think, I don't know cubed roots of fractions, but what we can do, and we'll talk about this later, is we can think of the cubed root of the top over the cubed root of the bottom. The cubed root of 27 is 3, and the cubed root of 8 is 2. And if we think through this to check it, we would do 3 halves times 3 halves times 3 halves, which does give us 27/8. And this last one, we have 100 millionth million here, square root of 100 million. That wasn't on our list, but if we think through, like 10 squared is 100 squared, and we think through our powers of 10, it's going to tell us how many zeros there are. So what squared would give us 8 zeros? Well, something with 4 zeros, so 10,000. So if you the square root of 100 million is 10,000. Coming down here, we have some variables in here. So we want to simplify these, and we worked through some similar to this before. But what's helpful sometimes is to write or think of this as how many perfect cubes of each variable do we have. So, and just as a reminder, I'm going to go ahead and take this 8 here. Remember, we can write this as 2 cubed, and that's another way to simplify numbers. If it's not in our list of perfect squares or perfect cubes, we can always change the form of it and factor this. So this is 2 cubed times x cubed, and then y to the 12th. I want to get some y cubes, so y cubed, and the reason I want that is because I should have an index out here of 3, because cubes and cubed roots cancel, so y cubed. Another y cubed, that gives me y to the 6th. I want to get all the way to y to the 12th, so another y cubed gives me y to the 9th, and then another y cubed actually gets me right to 12. And so we can simplify. The cubed root of 2 cubed is just 2. Cubed root of x cubed is x. And the cubed root of each of these y cubes is just y. So this is the simplest way to think through this. And then we can rewrite this in exponential form. We have y to the 4th. The next one, we have 4th root. So 81 is, if we think of 81 over here, 81 is 9 times 9. And that's 3 and 3 for both of them. So 81 is actually 3 to the 4th. So we're going to rewrite this as the 4th root of 3 to the 4th, a to the 4th. If I use 4 of these, I'm now down to 12. So do another a to the 4th. That's 8 in there now. Another a to the 4th. It's 12. A to the 4th again is 16. And then see if we can squeeze in here. We have a b to the 4th, and then another b to the 4th. Separate this here. And we can take the 4th root of all these, and they work out nicely. So we have 3, a, because the 4th root of a to the 4th is just a. So we have those, and then we have a b and another b. So we have 3, a to the 4th, b squared. There's our answer for that one. Over here, we're taking the square root of a negative. So as soon as we see square root of negative, we can even rewrite that right away as putting it with an I out here, because we can't square root of a negative. And now we can think through this. This is 3 squared, or we could have thought just the square root of 9 is 3. And c, well, to get to 12, there's c. There's 2, 4, 6, 8, 10, and 12. So this equals c to the 12th, but we're writing it like that because square root and squaring are inverses. So the square root of 3 squared is 3, and the square root of each of these, the square root of each of these c squares is just c. So I'll have 6 c's here, which we could skip writing them all out. If I have 6 c's, I can write it as c to the 6th.